All right, so this is section 1.6, compound and absolute value inequalities. These should all be review topics, and we will be adding some algebra 2 into that. So some of it will seem like review and some of it will seem new. So go ahead and pause your video, and right off the bat, go ahead and try these, see if you can remember from Algebra 1 how to do them. All right, and so I've showed a lot of my work here. In the steps that are in blue are what I call baby steps. So over here you see plus 9, plus 9, plus 9. Something when you're doing a compound inequality is that when you have two inequality signs in the problem like this one, that you need to add 9 to all three sides. Same down here, you have to divide -3 to all three parts, the left, the middle, and the right. All right, so those baby steps that are in blue, you do not need to show them. I did it for now just to emphasize the point in case you needed that refresher. This left-hand side problem is an and inequality. And over here, this one is an or inequality. The word or is always in an or inequality and kind of gives it away. So if you look at our final answer for number 1, first of all, notice that we reversed the inequality sign as we moved in this step. And the reason we did that is because we divided by a negative, you reverse the inequality symbols. Now, this is not how I'm going to leave my final answer. We want our final answer to match the number line, meaning we want our smaller number on the left and our larger number on the right, just like a number line. So I'm going to change this answer. I'm going to put the -4 on this side. The m will stay in the middle and the -7/3 will go on this side. But now I need to rearrange my inequality signs. Because I flipped everything, this inequality sign will come here and it flips. And the reason it flips is because the m was on the left and the -4 was on the right. And when you switch that, you reverse the inequality symbol. This symbol is now going to come over here and it also flips. So make sure that your equal to sign is still with the -7/3. So this would be my final answer. Smaller number on the left, larger number on the right. And that's an and inequality. So the way we would read this is we would say -4 is less than m and m is less than or equal to -7/3. So that word and is in there when you read it from left to right. Problem example number 2, we've got m is greater than 2 or m is less than -3. Again, we're not going to leave our answer like that. We want the smaller number to be on the left side and the larger number to be on the right side. So when I do this, I want to take this whole thing and put it on the left-hand side because it has the -3. Notice I'm not flipping the sign this time because I'm just shifting it. I didn't switch left and right-hand sides. The m didn't reverse and go on the right side of the inequality symbol. Same thing here. I'm going to take this guy and just move him over here. And that's my inequality for an or. Right? So now we're going to graph them. When it comes to graphing them, we're just graphing them on a horizontal number line. And you need to plot these numbers. So my rule is you need to label at least 3 numbers on your graph and you need to count by even intervals. So I know I need to go from -4 to -7/3. -7/3 is -2 1/3. So I like to include 0. You don't have to. So I'm going to go like this. So notice I did my tick marks by ones, but I labeled 0, -2, and -4. It kind of gives me some space, gives me some reference numbers, but I'm not labeling every single thing. Now I'm going to graph. So to graph this, I'm going to put an open circle on the -4 and a closed circle on the -7/3. For this one, you're just estimating where it goes. You don't need to label it because it's labeled in your final answer over here. So no need to double label it. The shading is everything in between these two numbers. So we just shade like this. Please do all of your graphing on the number line itself. So we're going to do the same thing for example number 2. You can count by any intervals you want. Just make sure that they're even intervals. So my tick marks are even intervals counting by ones, but I've labeled 3 numbers on my graph paper. So again, we're going to put an open circle on -3. We're going to put an open circle on 2. This time the shading is going out towards the arrows. So I want all the numbers less than -3, which go this way, all the numbers greater than 2, which go this way. Again, please put them on the number line and go all the way to those arrows. Don't stop short. And those are your graphs. Now we're going to say what if. So what if I changed the problem and the only thing I did differently this time was I just made that a -24. The whole rest of the problem stayed the same. So I put this like little squiggle here because this side of the equation would all still be the same. M is greater than 2. But what would happen on this other side? You would divide by -8. It would still flip the sign, but this time your answer would be 3. Okay? Now, this is the answer you're tempted to circle. And I'm boxing it with a dashed line because it's not the actual answer. Let's graph this and see what it looks like. And if you want to pause and try that yourself, please do. All right, so if I was graphing this, I would put an open circle on 2. I would put an open circle on 3. From the 2, all things greater than 2, I would shade to the right. So I'm shading to the right of 2. And notice that as I shaded to the right of 2, I kind of colored in that circle that's at 3. Now when I go to graph this part, I go from the open circle at 3 and I shade to the left. And notice I've colored in that open circle at 2. So you don't really leave your graph like this. Basically those circles go away. Okay. iPad did not really like that I did this. So those circles go away and all you're left with is a completely shaded graph. There's no circles at all. What does this mean? What's a solution for this, right? What is a solution to this inequality? All real numbers. That's your final answer. All real numbers. You can use that symbol, right? To make it, you kind of draw like the number 11 and then make an R through that. Or you can write the phrase, all real numbers. Please don't make up your own way of writing this. These are your only 2 choices, okay? No other abbreviations, right? So you would shade the whole entire graph for this. All right, example number 4. So this is where people start to forget what they learned in Algebra 1. So these are absolute value inequalities. So we're combining absolute value with an inequality and mushing it together. So just like when you solved absolute value equations, the first thing you want to do is isolate the absolute value. So we want to get this thing by itself. So we're going to add 2 to both sides, right? So we would have 3x plus 1 is less than or equal to 5. Now when we did absolute value equations, you went and you split the equation. You did 5 and -5. Okay, but we're not going to do that here. We're going to do something similar. We're going to turn this into an and problem. And the reason we're turning it into an and problem is because it's a less than or equal to sign. So anytime you see a less than or equal to sign or a less than sign, you're going to turn it into an and problem. So the way we're going to do that is we're going to put -5 on one side. We're going to put 5 on the other side. We're going to put the 3x plus 1 right in the middle. And then we're going to use this symbol in both locations. And that's your setup. Now from here, you're going to do this and you're going to solve the inequality. So I'm not going to show all that work. You can pause and finish it out. And that would be your final answer, right? And then my graph, I have a closed circle here. I have a closed circle on 4/3, which is right about here. And my shading would be in between. Okay. Over here, we have a greater than symbol. So it's the absolute value is already isolated, so we don't have to move anything around. When you have a greater than symbol, it becomes an or problem. So think greater, right? That's like the little mnemonic device we say, greater. So it becomes an or problem. This time you need the word or in your problem. Okay, so or goes in the middle. We're going to recopy this whole entire thing, and it's going to go on this right-hand side. We lose the absolute value. Then we're going to take this highlighted yellow piece, put it on the left-hand side, but we're going to do the negative. We need negative 13. So not only do we need negative 13, we're also going to reverse the inequality symbol, right? So if you set this up correctly, your inequality symbols, right, this one and this one, should be pointing out away from each other, like left and right. If you set it up correctly, that's a good check. They should be going out, just like your graph will in the end. So now we're going to solve this one individually. You can pause and do that. I'm not going to show all the work. And then same thing over here. You would solve all that. So this is your final answer. Your graph, counting by ones. I just can't change colors here. So I need a closed circle on 3. I need a closed circle on negative 4/3, which is about here. And then my shading is going out. All right, last example. So we look at this problem, we see that we have a greater sign, right? Greater. So this is going to become an or problem. The absolute value is already isolated, so I don't need to move anything around. So we're going to use the same setup we just did on example 5. We're going to put the word or in the middle. We're going to recopy this whole thing and put it over here. I'm just going to lose the absolute value bar. Then on the left-hand side, I'm going to recopy just the absolute value piece. And then I'm going to switch the inequality sign. And I have to do the negative version of this, the negative version of that. So kind of like we did the other day with absolute value equations, I'm going to put a negative sign, 3m plus 5, and distribute that negative sign. So your setup would look like this. 2m minus 1 is less than negative 3x minus 5. You can just jump straight to that step I just wrote. And then this side, I'm not going to change right now. So this is your setup. Once you get it set up, Algebra 1 skills for solving. So I solve this whole thing. It becomes m is less than negative. Oops. How did I get an x in there, guys? Wonder if you were screaming at the screen. M is less than negative 4/5. Or solve this whole guy using your amazing Algebra 1 skills. You get m is less than negative 6. And again, I'm going to dash this because it's not your final answer. Go ahead and pause, maybe graph it, see what you think this means. Right? So I'm going to graph it to kind of figure out what this does mean. So I have an open circle on negative 4/5, which is right around here. And then I shade left. Right? Or I have an open circle on negative 6 and I shade again left. Right? This is not what your graph is going to look like, right? This circle at negative 6 is shaded, right? The shading from negative 4/5 went right through it. So we're not going to leave our graph looking like this, right? We're going to make it a nice, pretty, just everything is shaded from negative 4/5 to the left. So I need my answer to match what my graph looks like. So my graph is this answer. M is less than negative 4/5. So my or problem changed into just a regular linear inequality with one inequality sign. So that's a little bit more of a Algebra 2 level question. Right, so I would like you to try these problems and bring them to class, number 13 and 15. There's no absolute value in these, they're just a review, but we are going to use them in class. They come from the textbook, page 45. Please make sure that you did all of the questions for this lesson, because we're going to use our graphs and our answers to do something more advanced. So if you just watched this, make sure you go back and get all the notes written down. All right, see you guys soon.